Okay, this next one is number 10. It's somewhat similar to number 9. There's a pretty key difference, and I'll talk about that at the end. Number 10's, I don't know, probably harder. Maybe not. It says, number 10, you have a 216 meter squared rectangular pea patch enclosed by a fence. I'll just draw a picture. So I have a rectangular pea patch, and I know the area of it is 216 meters squared. It tells us right in the first sentence. It's enclosed by a fence and divided into 2 equal parts by another fence parallel to one of the sides. So another fence parallel to one of those sides. So it's either like this into 2 equal parts or like this into 2 equal parts. And it doesn't matter which way you do it. I'll do it this way. So those are both equal areas. Let's see. What dimensions for the outer rectangle will require the smallest total length of fence? And how much fence will we need? So we want to get the smallest total length of fence in order to make the area be 216, and we'll have 2 equal parts in there. So again, for area, you got length times width, right? Length times width. But we're not trying to maximize or minimize area. We know the area has to be 216. So I know a little substitution here. I know when I do my length times my width, I have to get 216 meters squared. So there's that condition. I'm trying to minimize how much fence I actually use. So we need to, that said, whenever you know what you have to minimize, I'm minimizing how much fence I want, we have to write an equation for how much fence we're going to use. So we can call it f of x, I guess, for fence, or a fence function. F of x, how much fence will we have? Well, we'll have this plus, that could be one piece, I guess. This plus this plus this plus this plus this. Basically, we have 2 pieces that are that long, and then we have 3 pieces that are that long. So we need to add up all those lengths. Well, we can pick any side we want, call it x. It doesn't matter how you do it. I'll pick this whole side right here. That's going to be x. Well, if I know that whole side's x, and I know, so basically that's like my length, right? My length is x. Well, then my width, can't I just, I don't want to put w, I can't have 2 variables, so I'll solve for w in terms of x, divide both sides by x. So my width has to be 216 divided by x, right? Because like whatever that is, I have to multiply it by this to get 216, so 216 divided by this better give me x. So this is 216 divided by x. Well, now I just write a function for my length. I know I need 2 of those, so that'd be 2x. Plus I need 3 of those. That's 3 times 216 over x. This is a calculator one, so we'll actually do it as a calculator one, just for a reminder. What am I trying to do here on this one, though? I'm trying to minimize this, right? We want a minimum, because we want the least amount of fence possible. We don't want to buy a bunch of fence. So I'll just graph that. 2x plus 3. You could simplify it first, or you can just type it in your calculator like that. It doesn't matter. So that, and then before you even hit graph, because it'll probably give you some stupid picture that doesn't look right, it might help to just think about domain and range first. So like x for my window, I can't have negatives, right? I can't have a negative side length, so I'll just start at 0. And then the max, what's the longest fence I'm going to have? Well, if my area is 216, I'm pretty sure I'm not going to want to go over 216 meters one way and just have it 1 foot wide. It's probably not going to be my most efficient way of, I don't know, maybe, but I think it would be safe to put 200 there. Like, I don't think we're going to go bigger than that. If it looks like it's going to go be a minimum on the up to the right of that, we can change it later. And then my y value, well, you think y value is, in this case, how much fence you use. Well, if each side's if that's 200, that would be like another 200, so that'd be 400, maybe another 100 in there. We ain't gonna go over 500 meters in fence. So I'll go from 0 to even 400 is probably enough. What the heck, let's put 500, doesn't matter. Now I graph, and hey, doesn't look bad. Remember I was trying to find a minimum for that? Looks like right there. So you hit second, calculate the minimum. Left bound, I'll just push 0, and it'll start searching over there. Right bound, I don't even remember, wasn't that like 400? Who cares? Whoops, nope. Go to. Whenever that happens, if you get an error and it says quit or go to, push go to, and it'll take you where your error is. So 400 must be off the page, I don't remember. Oh yeah, my maximum X was like 200. So let's go 180, I don't know, who cares? There we go, so it's going to search between 0 and 180 for the min. Guess you can just hit enter again. The calculator's fast. It just takes it longer if you don't move it closer. But it literally only took like 1 second anyway, so who cares? So my minimum value is when X equals 18. So we got a min when X equals 18. So what's that mean? Well, that means this needs to be 18 meters. So the outer rectangle will be 18 meters, and then this one, 216 divided by 18, which is 12, I think. Yeah. And then, so what is the minimum amount of fence we could use? Well, we could have just looked right here. The Y value was 72. Remember, our Y value was how much fence we're using. So we're going to use 72 meters of fence. If we add that up, 12 plus 12 plus 12 is 36, plus 18 plus 18, another 36. So yeah, it'd be 72. It's right either way. The one you're supposed to do is a little different because you don't know the area. It just says a rectangular plot of farmland will be bound on one side by a river. So whatever, here's a river. Doesn't matter how you draw your river. You can go down and go left or right, or doesn't matter. And divided. Oh, whoops, wrong problem. The other 3 sides by a single strand electric fence. So here's my river. And then I'm going to put an electric fence around there. You've got 800 meters of wire. Not 800 meters of wire. What dimensions for the outer rectangle? Nope, I keep reading the wrong problem. What is the largest area you can enclose, and what are its dimensions? So this one, you know how much you have, and you want to find the largest area. Well, again, you know area is length times width, so just get it all in one variable for your length and width, and then your equation that you want to maximize will be area equals length times width, all in one variable. And then use your calculator, maximize it, give the dimensions.